What's up, guys? Johnny here. Welcome back to my channel. Today I have something for you which I found really interesting. Some results I kind of expected, but some of the results really caught me by surprise. Some of you may have noticed during my initial review of the EMAX 2306-2400Kv motors that while looking at the DVR footage, if I gave that copter a lot of throttle, you'd really see that voltage sag down. You can check out the review up here in the corner. From seeing earlier reviews on these motors, I knew they could draw a lot of amps. In fact, that was one of the things that kind of kept me towards the 2400 kV motors versus the big brother 2750 high kV version. Those are just pulling insane amps on the bench test. Even the 2400 kV motors were pulling 45, 46 amps. I knew these motors had the potential to really destroy batteries. For that reason, I decided to do some battery shopping and pick up a few different samples and see how they do with these motors. Before I get into that though, I want to take a little bit of time and explain to you guys why the velocity of my videos has kind of taken a little bit of a turn downwards. Unfortunately, I've actually torn my Achilles, and that's really prevented me from being able to do the things that I want to do. Being able to go to the places I want to go to and take you along and show you the things that I want to show you. It's made it really difficult on me just to get these things done. I have my walking boot now. I have crutches that I use with my walking boot. I even have a handicap sticker that I use, so I have to park too far away. But that's okay, right? I get to fly drones. Who needs to walk when you can fly, right? All things considered, I think I'm incredibly fortunate. You know, I live at a time where there's such an amazing hobby as flying drones. It's something that I have the means to do. You know, very few people in the world get to do something as awesome as fly drones FPV, and that's something I get to do and I get to enjoy, and then I get to share with you guys. So overall, I just consider myself very fortunate with the things I get to do, and hopefully we get this Achilles problem knocked out and we'll be back to doing everything like we used to do. Anyways, let's go to the tests with the batteries. So when I was watching a recent review from Joshua Bardwell on one of his battery tests, I noticed there was a few batteries that were kind of standing out in his test that I figured I'd pick up and try for my own tests. I really enjoy the videos by Joshua Bardwell. He shows some interesting perspectives on how they draw at 60 amps, which for a lot of setups that's a good draw for a good period of time. But I had a feeling we're probably drawing more than 60 amps with these motors. So I decided to try to put them to the test in something that I consider more of like an actual flight and see how they do. So after seeing what worked well there and having a 10% off coupon for ReadyMadeRC.com, I decided to navigate to ReadyMadeRC.com and pick up a few of the batteries. I decided to try out the Bonka 1300 high voltage pack, the ReadyMadeRC Orange 1500 pack 70C, the ReadyMadeRC 1800 mAh Orange 70C battery, and then finally the STRIX 95C 1550 mAh battery. If you're not familiar with the STRIX brand for batteries, it's actually just a rebrand of the Tattu R-Line 95C that you see have become really popular. So any results you see with the STRIX battery, they should be identical to what we would see with the R-Line battery. Now, I knew from the start of these tests I wanted to be harsh on the batteries, and that's why I decided to run these tests with the Racecraft 5051 tri-blades. They have a very aggressive pitch to the blades, and they're known for being very amp heavy and drawing a lot of current out of batteries. There are primarily two things that I was looking to test for here with these batteries. First is, what's the punch difference between batteries? If I give it full throttle, do I get more of a difference in one battery versus another? Do I go faster? Do I go further? Do I have more hang time? And the other thing is, what's the impact on the battery of doing that maneuver? You know, how much sag do I see in the battery when I do that? Right? Does it sag way down? Does it sag just a little bit? What's likely to last longer in that battery? To provide a frame of reference, I put up the 4 new batteries that I purchased against my 2 staples that I've always been using. And that's the Tattu 1300 mAh 75C battery and the Tattu 1550 mAh 75C battery. Take note that it's not really a totally fair comparison. I have about 20 cycles on my 1300 mAh pack, and I have about 10 cycles already on my 1550 mAh pack. Versus the 4 that I picked up are brand new. This is the first time I'm running them through tests. Also, due to my aforementioned injury, I'm also going to be doing all of my testing here in the backyard. Ideally, I would have gone somewhere else. It'd be a little bit easier to do these tests, but I'm sort of confined and restricted right now, so they're all going to happen here in the backyard. So I'm not doing anything too precise, too scientific here. All I'm really looking to do is to round the tree in my backyard and then just do a punch out roughly for about a second or so, see how high it goes, see how low the battery sags, when I flip around, about where am I positioned, and let that kind of tell me what it'd look like doing a quick punch-out maneuver. I figure those sorts of results should match whether I'm doing something like racing around the course on a straightaway, or if I'm doing freestyle, I'm trying to do, a punch-out and floating maneuvers and things like that. Now, ideally, I'd have a current sensor on this craft so I could really see how many amps are being drawn during these maneuvers. Unfortunately, I don't currently have one. So for these tests, all we're going to be able to do is take a look at the voltage results on the OSD to see how much the battery's sagging. Maybe in the future I'll have a current sensor, and that could provide additional information for any future testing that we do. Now, to start this test, I want to show you side-by-side GoPro footage of the punch-outs. I want to use GoPro footage and not label which batteries which, so I don't give you any preconceived notions based on what you might expect to be better or whatnot. I want you to make your own conclusions based on what you see. Do you see a difference between these batteries? Is one performing noticeably better than the others? So I'm actually pretty happy with how that punch-out worked out. I accelerated for roughly the same amount of time for each of the batteries. I turned over at roughly the same spot on each of the batteries. I feel like they gave a pretty good comparison for just how that very first punch-out did on each of these batteries. Note that the trajectory wasn't exactly the same, so that might be showing some differences in kind of where positions are, or maybe some of the warping at the edges. So it's not immediately easy to see necessarily where each copter is relative to each other. So do you guys see any difference between these? Do any batteries jump out at you? I know for me, two of them definitely jump out at me over the others. And I'm going to call those 1A and 1B. And I'd say there's one battery that's just barely behind, and I'll call that battery 3. So for me, it's the top right and top bottom. Those clearly were 1A and 1B to me. They seem to get the most punch. They seem to go just a little bit further than the other ones. It seemed like there's something extra there. And then if you look at the top left, I think that one came pretty close. Not quite as good as the others, but that's probably third place. And the others are noticeably behind that, at least to me. What do you guys think? Now, keep in mind, there's a number of variables happening here, right? The positions are different. I could have been a little bit longer on one. Who knows what. So this is not an end-all scientific thing. It's just we're going based off of these initial observations. All right, so now let's take a look at the DVR footage where we can see the voltage for each of these punch-outs. I'm also going to slow down the footage for you, just so you can have a better idea what the voltage readings are during the punch-outs for each of the batteries. Alright, so obviously that gave away which one was the high voltage Bonka battery. But what about the others? In case you missed it, I'm going to put up the minimum recorded voltage readings for each of these during this punch-out. Holy battery voltage sag Batman. If you're anything like me, you're kind of cringing at some of these results. There was some serious sag in some of these batteries. I actually found it really interesting that the high voltage pack actually sagged more than two of the non-high voltage packs. It makes sense why a battery pack with more capacity should be able to pull more current than a pack with lower current, but the high voltage pack has a lot of additional voltage to make up for that. Based on that, do you guys know which battery is which? Let me know in the comments if you wound up guessing these batteries correctly. So I'm going to go ahead and label each one of these batteries for you. Does that match what you expected? I will say very subjectively, when I was doing the flying, it felt like the STRIX battery just had a little bit more than the others. I liked the feeling. It felt like it was pulling a little bit stronger. It felt better to me when I was flying. Now, the battery sag results seemed to line up with what I was feeling. That STRIX did really, really well compared to the rest of the other batteries. The ready-made RC 1800 also did really well there. However, even though it didn't sag as much, I feel like that extra weight of the 1800 mAh pack was really hurting it, and that's why you didn't see that same punch compared to some of the other batteries. I will say when I was flying around and not just doing a full punch out, the added weight wasn't as noticeable, but I did throw these on the scale and get an idea of what each one weighed compared to the others. When I put the 1800 mAh pack on the scale, it weighed in at 212 grams. That's quite a jump up from the 1300 mAh pack. That Tattu 1300 only weighed in at 150 grams. The STRIX battery weighed in at 199 grams, followed by the Tattu 1550 mAh at 184 grams, the Orange 1500 mAh at 177 grams, the Bonka battery at 159 grams, That's quite a considerable jump from the 1300 Tattu battery, which weighed in at only 150 grams. So after seeing these results, naturally, I wanted to see if these results stayed consistent. On each subsequent punch-out, did I keep seeing the same punch from each of the same batteries? Was there similar lag on each of the punch-outs? Note that I actually crashed after my first punch-out with the STRIX battery, so the flight time you see in the DVR footage will be a little bit later than the others, but it's at the same punch-out during my testing. For me, I actually found these results really consistent across these runs. I feel like we have pretty accurate numbers and we keep repeating them. So I think that speaks to the results we've seen so far. In case you missed it during those punch-outs, I'm going to put the lowest recorded battery sag values across each of those batteries, across all 5 of those punch-outs. Again, keep in mind that each punch-out could have been slightly different. One might have been subject to slightly longer punch-outs than another, and that could be contributing to some of these differences that we're seeing. However, you see that the 1300 mAh Tattu battery really took a beating in these tests. It recorded the lowest voltage of 11.8 volts. Really impressive to me was both the STRIX and the Ready-Made RC 1800 mAh packs. Both reported the lowest sag of 12.9 volts, and only crossing the 13 volt line just one time during those 5 different punch-outs. With the smaller size and weight of the STRIX battery compared to the Ready-Made RC battery, that seems like the winning combination to me right now for freestyle and race flight, at least for me. All of that being said, are we really comfortable seeing that kind of sag out of our batteries? Do we want to subject that kind of a beating to our batteries every time we fly this copter? How long will they last, even being punished down to 12.9 volts on a 1-second punch-out? These are really expensive batteries, and I don't want to hurt the lifetime of these batteries too much. So I decided to take these tests a bit further. What does it look like if I run different propellers on these? What sort of results do I see there? I'm running a really aggressive prop. Let's try toning it down a little bit and see what differences we start to see. Right, and ultimately, what prop do I plan to keep running whenever I fly my EMAX 2306-2400Kv motors? To me, this is where the test really started to get interesting. For this round of testing, I'm going to take the GemFan 5040 tri-blades and the Dal Cyclone V2 5046C propellers and put them up against the Racecraft 5051 propellers that we just used. First off, I'll say subjectively, I enjoy flying all these props on this copter. They all feel great. They all definitely have punch. They're a lot of fun to fly. I enjoy them all. I definitely notice I get a little bit more flight time when I'm flying with the 5040 tri-blades, but it's not such a difference that it makes a real impact on my choice to fly one or the other. So anyway, let's get on to the test. What I really want to see is the power I expect to give up with the 5040s, is that enough to justify the efficiency gains as I fly with the 5040 tri-blades? Again, I'm going to do the same test we just did with the Racecraft brands, comparing across the batteries, but now I'm going to do it across different propellers. So I'm going to go around the tree, do the same punch out, do it for about 1 second, and see what I see as far as differences. Was there a noticeable punch difference? What about the battery sag levels? To do these tests, I'm only planning to test with both the STRIX and the Ready-Made RC 1800 mAh packs. Those performed the best in my prior testing, so I figure that's all I really need to test for these testings here, as that seems to be the most likely battery I'm going to use going forward. Again, I feel like I got pretty consistent results with those punch-outs. I punched out about the same amount of time, I flipped out right around the same time, maybe slightly earlier on one of the props, but they're all pretty close. It gives a good idea of the relative performance, I think. Do you guys see any difference here between these 3 different props? Does one of them stand out over the other to you? Could you guess which prop is which of these 3? To me, in this test, one prop stands out head and shoulders above the other 2. Do you guys agree? For me, it's the prop all the way on the right of the screen. I'm going to show it again, but slow it down this time. To me, the single biggest thing I'm looking for in these tests is that punch-out momentum. It's that feeling when you flip around and you're still going up. It's the sense that gives you that floating, it's that floaty feel, it's that hang time that just is so addicting in freestyle flight. So ultimately, which prop threw the craft the hardest into the air so that it kept carrying its momentum as it rose up? Again, to me, looking at it that way, it's the prop on the far right that seems to carry momentum for the longest amount of time. That's the one that's the most fun to me. Honestly, based solely on that momentum fact alone, that's probably the prop I want to be running moving forward. I'm going to go ahead and show it again one more time full speed and show 2 more runs of those tests. What do you think? Were the results consistent across each of those runs? Did it show different results? I felt they were pretty consistent. I'm pretty happy with those results. I think we're seeing what gives the best punch-out performance. Now, before I move on to the sag values of these batteries, I want to also show you the ready-made RC 1800 milliamp hour results. That way we won't yet be able to know which prop it is, and make sure it's not just differences in this battery versus that batteries. Let's make sure that the results are still consistent across batteries. Then we'll get into the DVR footage with the battery sag values. On that first test, I think it's clear that I stopped a little bit earlier on the far left prop, so that's a little bit of a disadvantage. And in this punch out, I actually feel like I like the middle prop and kind of how it felt there. However, on the second punch out of the ready-made RC battery, I feel like the far right prop again seems to be performing the best. Followed by the middle prop, and then followed by the left prop, I think, after that. In the last test, it's a little bit hard to say, but I do feel like I got slightly better results out of the far right prop. So based on those tests alone, do you think you know which prop is which? Can you tell, like, which battery you expect to be sagging the most or the least based on these results? Could you guess which one goes to which? I remember when I first saw these results, I immediately thought the GemFan 5040 props would be on the far left, the Cyclone V2 props would be in the middle, and the Racecraft 5051 props would be on the far right. Given that the Racecraft has the most aggressive pitch, I figured that should give the most amount of thrust. So similarly, when I look at the voltage sag values, I expect the Racecraft value to have the most sag and the 5040s to have the least, and we should see those line up on each of these. Let's dig into the voltage sag values, first looking at the STRIX values, and then looking at the ready-made RC 1800 milliamp hour values. Again, I'm going to slow things down just to make it a little bit easier to see the readings that are coming out from the OSD for the battery voltages. Were those the results you were expecting? I know for me, I was shocked when I first saw this. In case you missed it, I'm going to go ahead and label the minimum recorded battery voltage sag value across each of these props, and hopefully that helps you out. Did those results match what you expected? I know when I first saw it, I was absolutely shocked. I thought for sure that the prop that had the most amount of thrust was going to have the most amount of sag to go along with it. But you see here, that's obviously not the case. At this point, you should be able to tell which prop is which spot on the screen, but I'm going to go ahead and add the labels on there for you. Now, just to verify the results from these tests, I'm going to go ahead and do the same thing with the ready-made RC 1800 milliamp hour pack, just to make sure we're not seeing some differences between those two batteries. On both the GoPro and the SAG results, I would say the results are pretty consistent with what we saw with the STRIX battery. Showing the lowest recorded battery voltage sag value across the three different props of the ready-made RC batteries, I say the sag's a little bit worse than the STRIX battery, which seems to support our earlier findings, which shows that the STRIX is likely the most superior battery in this particular round of testing. So in conclusion, what have we learned from all this? I guess I would say primarily two things. First of all, the STRIX batteries are amazing batteries. They don't come cheap, but they seem to perform really, really well. It'll definitely be interesting to see how these batteries hold up over the long term once they start to have more and more cycles. Is it worth that hefty price premium you pay over the ready-made RC Orange batteries? You'll have to decide that for yourself. But it's certainly a compelling question if you ask me. What about some of the cheaper options you can buy out of China, like the Infinity Graphene batteries? I do plan on picking some of those up someday and be able to compare those to these. I am curious to see what you can get for a lot less battery. But if you're looking for the best performing racing or freestyle battery right now, it does seem to be that STRIX battery that really stands out. And keep in mind, the STRIX is also just a rebadge of the R-line Tattu batteries, so either one are really fantastic options, it looks like in my testing. So if you're running the EMAX 2306-2400Kv motors, it definitely seems like these batteries are worth checking out if you want that little bit of extra punch and a little bit less sag. Now, for the part that I found the most interesting in all these tests, that's the prop differences. I was really not expecting to see the results that I saw during my testing. From what we've just seen, it really looks like the Racecraft 5051 props really don't make sense on these motors. They provide less flight time than the other two motors, they provide more sag, and they also don't even provide more thrust than we're seeing on the other props. So even though I do enjoy flying them, just like I enjoy flying the other props, I don't think I'm going to be putting them back on this craft anytime soon. The GemFan 5040 props were extremely impressive to me. The results in flight time overall were the best. They came very close in thrust compared to the Dal Cyclone props, I thought. I really expected the 5040s to struggle on these tests. I figured at 2400 kV, you're really going to need a more aggressive prop compared to the 5040s, and the 5040s would really be better suited towards flying on the 2750 Big Brother high kV version of these motors. When I typically fly my 2600 kV motors, I always like to run the 5040s. They work great there. I just thought at a lower kV, we'd really need that aggressive pitch to really see that difference. So in the end on these testings, I think I'm going to stick with the Cyclone V2s. If only for that little bit of added momentum that I get when I do my punch outs, I just love that feeling of floating. It gives me that for slightly longer while also not destroying the battery as much as the Racecraft props. It seems like a winning combination for me. But at the same point, I know that, if I have a set of 5040s, I can always slap that on there and get tremendous results, almost as good as what I'm seeing out of the Dal Cyclones. That's really good for me to know moving forward too. So anyways, guys, that's going to go ahead and wrap things up. I really enjoyed doing these tests. I found the results super interesting. Hopefully you guys found them super interesting too. I really hope it proves to be helpful for you in the future too. What did you think of these tests? Did you find it helpful? Did I do something totally wrong, or do you think that I followed the wrong way of doing these tests? Is there something I could have done that you would have preferred to see? Do you have different testing methodologies that you use? Maybe things I could learn from going forward. What results have you gotten? Have you drawn different conclusions that I have? I would love to hear from you. Let me know in the comments below. I'm really curious to see what sort of results you guys are having. Alright guys, I'll catch you later. Peace.